So good day to each and every one of us. So for today's lecture video discussion is we will be discussing all about the biological effects of radiation. Okay, so now radiation interaction with the biological systems occurs at the atomic and also the molecular levels, resulting in the damage to cellular structures and also molecular processes. So the primary mechanisms of radiation interaction in the biological tissues depends on the type of radiation and also its energy. So the biological effects of radiation are largely driven by the interaction of the ionizing radiation with molecules, particularly seawater, which makes up a significant portion of biological tissue. So here are the concepts. So first one is we will be discussing all about the types of radiation and also their effects. So we have two types of radiation. The first one is the ionizing radiation. So this includes we have X-rays, gamma rays, and particle radiation, which are the alpha and beta particles as well as the neutrons. And ionizing radiation also has enough energy to remove tightly bound electrons. So from the atoms, creating ions which can lead to significant biological damage. So that is the first type of radiation. The second one is the non-ionizing radiation. So si non-ionizing radiation, this includes si ultraviolet, the visible light, the microwaves, and also the radio waves. So kani sila nga radiation doesn't remove the electrons from the atoms, but they can excite atoms and molecules, causing heating and other molecular changes, such as in the case of the UV-induced DNA damage. Now, we also have, let's talk about two types of action of radiation. So we have the two types, or radiation interacts with its biological tissues through these two primary mechanisms. We have the direct and indirect actions. So si direct action, so this direct interaction occurs when radiation directly hits and ionizes critical cellular structures such as the DNA, the proteins, and also the cell membranes. So DNA is a particularly sensitive target because the damage to the DNA can lead to mutations. We have cell death and also carcinogenesis. So we will be discussing each of that later on. And also we have the double strand breaks, the DSBs in DNA, are especially harmful as they are more difficult for the cell to repair. So again, we will be discussing this terms later on in this video discussion. And also we have the indirect action. So this happens when the radiation interacts with water molecules, producing reactive species such as the free radicals. And also these free radicals are highly reactive and can cause oxidative damage to the DNA, the proteins, the lipids, and other cellular components, leading to the cell dysfunction or even cell death. So now let's talk about the different types of cellular damage na mabuhat ni radiation. So the first type of cellular damage is, of course, we have the DNA damage. So kani siya si DNA damage, this is the most critical target for the radiation. So in the cell nucleus, so si DNA good. So radiation also can induce single strand breaks. We have double strand breaks, base damage. So again, we will be discussing each of these terms later on. So again, the first type of cellular damage is the DNA damage. So mo ni ang pinaka-critical nga target for the radiation. The second one is the protein damage. So si proteins, particularly the enzymes and the structural proteins, can be inactivated or denatured by radiation. So through the disruption of cellular functions such as repair mechanisms, cell signaling, and metabolism. And then the third one is we have the lipid membrane damage. So si radiation-induced lipid, we call it radiation-induced lipid peroxidation, can damage the cell membrane, causing the leakage of cellular contents and eventual cell death. So, those are the three common types of cellular damage nga maapektuhan ni ang damage nga ma-cause ni radiation. Okay, so now, how about the radiation sensitivity of different cell types? So, dili tanang cells, not all cells are equally sensitive to radiation. So, there are cells that are rapidly dividing and also have high metabolic activity, and there are also more susceptible to radiation damage. So, kani sila, these are, number one, the stem cells and the progenitor cells. So, these cells are critical for tissue regeneration. So, they are highly sensitive. We mentioned here, they're highly sensitive to radiation. And the second cell type is the cancer cells. So, si cancer cells, due to their rapid nga proliferation, so cancer cells are generally more sensitive to radiation, which forms the basis for radiation therapy in cancer treatment. So, now how about the tissue and also the organ effects due to radiation exposure? So, si radiation exposure manggod can affect the entire tissues and organs depending sa dose and also the radiosensitivity of the tissue. So, we have the first one, which we call the acute radiation syndrome, or ARS or ARS. So, kani si acute radiation syndrome, it is caused by high dose of radiation exposure, so which is characterized by damage to rapidly dividing cells in the bone marrow. In the bone marrow, we have the gastrointestinal tract or GI tract, and also the nervous system. And then the second one is we have the long-term effects. So chronic exposure to lower doses of radiation can lead to long-term effects, like we have here cancer, we have fibrosis, cataracts, or cardiovascular diseases, depending on the tissues nga exposed. Okay. Now, na-mention nato last time na we have the single strand breaks, double strand breaks, and so on. So, these are the types of the DNA damage nga na-cause ni radiation. So, we will be discussing each of this. We have here the single strand breaks, the double strand breaks, and we have other forms of DNA damage as well as the DNA repair mechanisms. Okay, so let's start with the single strand breaks or the SSBs. So what are SSBs? So SSBs or single strand breaks occur when radiation breaks one of the two DNA strands. So this is generally less severe than a double strand break as the complementary strand remains intact, providing still a template for repair. So, unsay may cause? What are the causes of SSBs? So the first one is the direct radiation interaction. So, si radiation can directly ionize the backbone of the DNA, breaking the phosphodiester bond on one strand. As for the indirect action, we have the reactive oxygen species or ROS, such as hydroxyl radicals generated through the radiolysis of water, can attack the sugar phosphate backbone, causing the strand break. So, those are the causes of single strand breaks or kung ano nagkakahitabo si single strand breaks. Now, what are the cellular implications of SSBs? So, the first one is repairability. So, kaning SSBs are easy to repair because, again, the complementary strand is still intact. So, the most common repair pathway is what we call the base excision repair or BER, which detects the break and uses the DNA polymerase to fill in the gap. So that is the first implication. The second implication is the consequences of misrepair. So kung ang SSB or single strand break is not correctly repaired or ma-misrepair siya, or if the repair fails, it can stall DNA replication or transcription, leading to we have mutation, loss of genetic information, and or apoptosis. So we will be discussing apoptosis later on this lecture video. And then the third implication is the conversion to DSBs or the double strand break, which we'll be discussing next. So if an SSB or single strand break is encountered during DNA replication, so it can be converted now into a DSB or double strand break, which is far more dangerous for the cell. Okay, so again, those are the 3 cellular implications of single strand breaks. Now, how about the double strand breaks? So, kinsa naman po ni si double strand breaks? So, what are DSBs? So, double strand breaks occur when both the DNA strands are severed simultaneously, which is a severe form of damage as there is no complementary strand to guide repair. So, kung si single strand napay nabilin na complementary strand or napay intact nga complementary strand, paabot sa double strand breaks is damage na gid ang both DNA strands. So, DSBs are particularly lethal to cells if not properly repaired. So, what are the causes of DSBs? So, kung sa direct radiation interaction, there is a high energy ionizing radiation like gamma rays or particle radiation that can directly cause the breaks in both DNA strands. And as for the indirect action, DSBs can also form when radiation-induced free radicals such as the ROS or the reactive oxygen species damage both strands of DNA at or near the same site. So those are the causes, or the direct and indirect action causes of DSBs. Now, what are the cellular implications of the DSBs? So the first one is severe damage. So DSBs are the most cytotoxic and mutagenic type of DNA damage. So this can lead, or they can lead to chromosomal fragmentation, loss of genetic information, and genomic instability, which are the key factors in carcinogenesis. And we also have the cell fate. So if dili ba repair si DSBs or double strand breaks, so they can lead to apoptosis, senescence, and also cancer. So those are the cellular implications of DSB. So we've discussed already the single strand breaks and the double strand breaks. Now, what are the other forms of DNA damage? So the other forms of DNA damage, we have first one, we have the base damage. So radiation can also alter the chemical structure of the individual DNA bases, so causing mismatches during replication. So this can result in point mutations, which, if in critical regions like oncogenes or tumor suppressor genes, can lead to cancer. And then the second one is the DNA crosslinks. So, radiation daw can cause covalent bonds to form between adjacent DNA strands, or what we call the interstrand crosslinks, or with the same strand, which we also call as the intrastrand crosslinks. So, kani sila nga mga crosslinks prevent proper strand separation during the replication or transcription, leading to cellular dysfunction. So those are the other forms of DNA damage. So dili lang kay si single strand break and si double strand break. So we also have the base damage and also the DNA crosslinks. So now, what are the DNA repair mechanisms? So cells manggod have evolved several repair mechanisms to deal with the radiation-induced DNA damage, especially the single strand and the double strand breaks. So the first one is the base excision repair, or the BER. So ang target niya is primarily repairs the single strand breaks and the base damage. So mo ni ang first na base excision DNA repair nga mechanism. So ang mechanism niya is it recognizes the damaged bases or SSBs. It removes the damaged portion and then fills in the gap using DNA polymerase and ligase. So this process is efficient and typically error-free. So that is the first type of repair mechanism. The second one is the nucleotide excision repair, or the NER. So ang target niya is it repairs the bulky DNA lesions such as the UV-induced thymine dimers or intrastrand crosslinks. So ang mechanism ani ni NER, it excises a short single-stranded DNA segment containing the lesion and replaces it with the newly synthesized DNA. So that is the second one. Now, we also have the third one, which is the non-homologous end joining, NHEJ. So, kani si NHEJ, ang target niya is to repair the double-strand breaks. And then, its mechanism, si NHEJ ligates the two broken DNA ends together without using a template. So, it is a quick repair process, pero prone to error siya, as small insertions or deletions may occur at a break site. So, kani si NHEJ is the primary repair mechanism ni double-strand break. So, this is the third one. And then, we have the fourth one is the homologous recombination or HR. So, ang target again niya is to repair the double-strand break. So, kani si number 3 and number 4, it repairs the double-strand breaks. So, kung si 1 and 2 is for the single-strand breaks, kani si 3 and 4 typically focuses on targeting sa double-strand breaks. So, kani si HR uses the undamaged sister chromatid as a template to accurately repair the break, ensuring that there is no loss in genetic information. So, kani siya nga pathway is error-free and active primarily during the S and G2 phases of the cell cycle when a sister chromatid is available. And then, we have the fifth one is what we call the mismatch repair or the MMR. So, ang target niya, it corrects mismatches that occur during the DNA replication, including base substitutions or small insertions or deletions. So, ang mechanism ni MMR is MMR proteins recognize the mismatch bases, excise the erroneous segment, and replace it using the correct template. So, those are the 5 DNA repair mechanisms. Okay, so now let's talk about the implications. What are the implications of DNA damage and repair for cellular function? Now, the first one is the genome stability. The second one is the cancer development. We have the therapeutic implications. And we have the cell cycle impact. So, those are the 4 implications of the DNA damage and repair for cellular function. Now, understanding these mechanisms helps in assessing radiation risk, improving radiation therapy, and also developing strategies to protect cells from the radiation damage. Okay. Now, let's talk about cell death. So, na-mention ni si apoptosis sa ato ang discussion beforehand. Now, let's discuss cell death. So, cell death includes the apoptosis, more on focus sa apoptosis, ang iyang significance in cancer therapy, and also the significance in overall cellular health. So, si radiation manggod can induce cell death through various mechanisms. So, dili lang kasi apoptosis. We have apoptosis, we have necrosis, mitotic catastrophe, and also senescence. So, among these 4 various mechanisms, si apoptosis manggod is one of the most critical and well-regulated forms of programmed cell death nga ma-trigger by radiation. So, we will be discussing more on apoptosis on this topic. Now, what is apoptosis? So, again, apoptosis is also known as the programmed cell death. So, si apoptosis is a highly regulated, energy-dependent process of programmed cell death that plays a vital role in maintaining tissue homeostasis. So, it is triggered when the cells undergo irreversible DNA damage or stress that cannot be repaired, including the damage that is caused by radiation. Now, what are the key features? Ano may mga key features ni apoptosis? So, the first one, we have the DNA fragmentation. Ang second is the cell shrinkage. We have membrane blebbing. formation of apoptotic bodies, and we have phagocytosis. So, mo ni ang mga key features di apoptosis or sa programmed cell death. Okay, so mentioning apoptosis, we have apoptosis nga pathways created by radiation. So, we have two pathways. We have first the intrinsic, or also known as the mitochondrial pathway. So, ang mechanism niya is the DNA damage caused by radiation activates P53, which is a tumor suppressor protein, which in turn upregulates pro-apoptotic proteins. So, kani sila nga mga proteins permeabilize the mitochondrial membrane, leading to the release of cytochrome C into the cytoplasm. So, we also have the caspase activation and also the cell fate of this pathway. So, ang cell fate niya, once initiated, the apoptosis leads to the orderly dismantling of the cell without causing inflammation. So, mo ni ang first nga pathway nga ma-activate by radiation. The second one is the extrinsic pathway. Extrinsic pathway or the death receptor pathway. So, ang mechanism niya, this pathway involves the activation of death receptors on the cell surface by external signals such as radiation-induced stress. So, also, we have the crosstalk. So, si caspase 8 can also cleave BID, which is a protein that connects the extrinsic pathway to the intrinsic pathway, now further amplifying the apoptotic response. Okay. Now, what's my significance of the radiation-induced cell death in cancer therapy? So si radiation therapy, it aims to eliminate cancer cells by inducing irreparable DNA damage that triggers cell death primarily through apoptosis, mitotic catastrophe, and also the other mechanisms. So, kani silang processes are critical for the success of radiation therapy. So, the first one is by targeting the cancer cells. So targeting cancer cells, we have the enhanced sensitivity and also selective killing. So, kani si selective killing, si radiation is designed to target cancerous cells while minimizing damage to surrounding healthy tissue. So, kani mangod si apoptosis is, it is an orderly process that avoids inflammation, which helps to limit the damage to the healthy cells and tissues. And also, ang second nga significance manggod ni apoptosis is minimizing the side effects. So, we have here apoptosis versus necrosis. So, kinsa man ni difference ni apoptosis and necrosis. So, si apoptosis manggod is a clean form of cell death that prevents inflammation. So, in contrast, sa kabaliktaran, si necrosis, it can cause damage to neighboring cells and tissues. So, that's why through apoptosis, or kung si apoptosis itong gamiton, we are minimizing the side effects. And then we have also here the mitigating toxicity. So, understanding mango the thresholds for apoptosis in normal versus in cancer cells, it helps the clinicians adjust radiation doses to minimize toxicity to healthy tissues. So, that is the second significance, again, which is the minimizing side effects. And then the third one is preventing recurrence and resistance. So, under the preventing recurrence and resistance, we have eliminating resistant cells. So, si apoptosis, it prevents the survival of damaged cancer cells that could otherwise accumulate mutations and become resistant to therapy. So, we also have mitotic catastrophe. So, kani siya nga form of cell death also plays a critical role in eliminating cells that evade apoptosis but are still damaged beyond repair. So, these cells die during defective mitosis, preventing the tumor regrowth. So, these three are the significance of the radiation-induced cell death in cancer therapy. Now, how about for the significance overall na cellular health? So radiation-induced apoptosis manggod is not only important sa cancer therapy, but also it plays a role in maintaining the overall nga cellular health by eliminating cells with irreparable DNA damage. So this has broader implications for, again, number one, preventing cancer. So by removing damaged cells before they can accumulate mutations, so si apoptosis acts as a safeguard against the development of cancer. So second one, we have the tissue homeostasis. And then the third one is the aging and degenerative diseases. So see, while apoptosis prevents the accumulation of the damaged cells, ang excessive pod ng apoptosis due to chronic radiation exposure can contribute to aging and degenerative conditions, as too many cells may be lost over time. So radiation-induced cell death is thought to play a role in conditions like cataracts, we have cardiovascular disease, and also neurodegeneration. Okay, so again, those are the significance for the overall nga cellular health. Now, what are the contribution of radiation-induced mutations to mutagenesis and carcinogenesis? So before we go to the contribution of radiation-induced mutations, let us define first kinsa ni si mutagenesis and carcinogenesis. Now, what is mutagenesis? So si mutagenesis is the process by which the genetic information of an organism is changed, resulting in a mutation. So this can occur naturally bakaha, or what we call the spontaneous mutagenesis, or it can be induced artificially, or what we call the induced mutagenesis through physical, chemical, or biological agents. So to define mutagenesis in a shorter term, it is the process by which the genetic mutations are generated. Now, how about carcinogenesis? What is carcinogenesis? Carcinogenesis is the process by which the normal cells are transformed into cancer cells. Or pinaka-easy definition for carcinogenesis is the development of cancer. Now, what are the types of the DNA damage that is leading to mutations? The first one is the base damage and oxidation. The second one are the single strand breaks. We also have the double strand breaks and the chromosomal crosslinks and aberrations. So those are the DNA types of DNA damage that can lead to mutations. Okay. Now, unsa may mga mechanisms ni radiation-induced mutagenesis? So we have the error-prone repair mechanism. So under sa error-prone repair mechanisms, we have the non-homologous end joining, or NHEJ. We also have homologous recombination, or HR. And we have the base excision repair. So this is under the error-prone repair mechanisms. The second mechanism is the chromosomal aberrations. So if misrepair manggod si double strand break during the cell cycle, it can result to deletions, translocations, inversions, and duplications. So that is under the chromosomal aberrations. The third one is the point mutations and small-scale mutagenesis. So example ani is the TP53 mutations and the RAS mutations. Now, we are done with the radiation-induced mutagenesis. Now, let's talk about the radiation-induced carcinogenesis. So we have 3 steps sa radiation-induced carcinogenesis. Number 1 is the initiation. Next is the promotion. And we have the third is the progression. So that is again the steps in radiation-induced carcinogenesis. Now, unsa man nga mga cancer types ang ma-associate nato with radiation exposure? We have the leukemia, we have the thyroid cancer, breast cancer, lung cancer, and also the brain cancer. So those are the cancer types nga ma-associate nato with radiation exposure. Okay, now let's talk about radiation sickness, or also known as the acute radiation syndrome. And also, what are the effects of this high dose radiation exposure to the body, different body systems? Now, again, so radiation sickness is also known as the acute radiation syndrome. So it occurs daw after exposure to high doses of ionizing radiation. So the severity and the type of the symptoms depend on the dose of radiation nga na-receive nimo, the rate of exposure, and also the type of radiation. Okay, so rapidly dividing cells in the body, such as those in the bone marrow, gastrointestinal tract, skin, and central nervous system. Okay, now what are the phases of radiation sickness? So we have 4 phases. First one is the prodromal phase or the initial phase. So ang common symptoms ni prodromal phase is nausea and vomiting. We have the fatigue, loss of appetite, diarrhea, headache, and fever. So the next phase is the latent or the latent phase. So after the prodromal phase, the symptoms may temporarily subside, giving a false sense of recovery. So abi nimo naulian na ka. So wala ng mga symptoms. But during this period ang atuang body systems, particularly the bone marrow and the gastrointestinal cells, they continue to deteriorate na So abi nato og naulian na data kay nawala na ang mga symptoms, but deep inside our sa internal sa ato ang body systems is nag-deteriorate na atong bone marrow as well as our gastrointestinal cells. And then we have also the manifest illness phase. So during this phase, ang symptoms is ni-emerge na po, nibalik na po siya. So these symptoms depend on the radiation dose and the type of the syndrome. So sa bone marrow ba kaha, gastrointestinal, or neurovascular. So symptoms range from mild to severe and can last for weeks. So in very high doses, death may occur within days. And then the last phase is either recovery or death. So depending on the radiation dose, the individual may begin to recover after the manifest illness phase. But for those exposed to lethal doses, death is likely to occur within days to weeks from the multiple organ failure or infection. Okay. So, let's talk about the symptoms nga mabati sa isa ka tawo based on the radiation dose nga na-expose siya. So, we have from low to moderate dose, from 1 to 2 grays. We have the prodromal symptoms, the mild nausea, vomiting, and fatigue may occur within 6 to 12 hours after exposure. We also have the latent phase and the recovery. So, most individuals daw recover, although some may develop long-term effects like an increased risk of cancer. Now, as for the moderate to high dose, which is from 2 to 6 grays, ang prodromal symptoms is moderate na karon nga nausea, vomiting, and diarrhea appear within hours. So, and then we have the latent phase. And as for the manifest illness phase, we have now the hematopoietic syndrome, which has symptoms of increased susceptibility to infections, anemia, bleeding and bruising, fatigue, and fever. So, sa recovery, so bone marrow may regenerate if the dose is at the lower end of the range. However, if walay treatment, such as blood transfusions or bone marrow transplants, death may occur from infections or internal bleeding. And then, for the high dose, from 6 to 10 grays, ang prodromal symptoms is severe na nga nausea, vomiting, and diarrhea, which will occur within 1 to 2 hours after exposure. Ang latent phase nato is short latent period, which is from hours to a few days. And as for the manifest illness phase, we have now the gastrointestinal syndrome, which leads to severe diarrhea, vomiting, electrolyte imbalance, dehydration, loss of appetite, and severe abdominal pain. And ang outcome ani, we have death is likely within 2 weeks without aggressive medical intervention, which are the fluids, electrolytes, baka, and antibiotics, as the body cannot absorb nutrients and infection or sepsis is likely. And then, ang very high dose na dayon, we have 10 to 30 grays. Ang prodromal symptoms is intense nausea, vomiting, diarrhea. So, it begins within minutes na. And then, latent phase. As for the manifest illness phase, we have the neurovascular syndrome, which leads to confusion, dizziness, severe headaches, seizures, loss of consciousness, and ataxia. So, ang outcome ani, death occurs within hours to days due to the massive brain swelling, cardiovascular collapse, and also organ failure. So, kani siya nga dose is almost always fatal. And we have last one, which is the extremely high dose, which is greater than 30 grays. So, immediate and fatal damage to the central nervous system and other vital organ occurs. So, death typically occurs within hours to a few days as the body's ability to maintain any homeostasis is now destroyed. So, muna siya ang mga symptoms nga ma-feel sa isa ka tao based on the levels of radiation or the dose of radiation na exposed siya. Okay. Now, unsa may mga effects sa high dose radiation on these different body systems? So, sa bone marrow, sa gastrointestinal system, sa cardiovascular and central nervous system, and also sa skin. Okay. Now, as for the bone marrow, radiation damages the stem cells in the bone marrow, impairing the production of blood cells. So, muna ang effect ni radiation kay bone marrow. So, an exposure of more than 2 grays severely impairs its function. Now, for the gastrointestinal system, si radiation destroys the lining of the intestines, leading to severe digestive problems and a breakdown in nutrient absorption. So, maapektuhan ang gastrointestinal system at doses of 6 grays or higher. So, without treatment, death will occur due to fluid loss, malnutrition, and infections. Now, for the cardiovascular and central nervous system, at very high doses or greater than 10 grays, the radiation damages the brain and cardiovascular tissues. So, sa maapektuhan ang atuang cardiovascular and central nervous system at very high doses. Now, for the skin, so radiation can cause damage to skin cells, leading to burns and ulcers. So, at doses above 3 grays, na kayo ma-feel na symptoms like erythema, blistering. Also, we have desquamation and necrosis. So, unsa may mga long-term effects ni radiation exposure? We have the increase in cancer risk. We also have cataracts, fibrosis, infertility, and chronic health problems. So, these are the long-term effects of radiation exposure. Now, unsa man pud ang medical treatment for radiation sickness? So, treating the radiation sickness focuses on managing the symptoms, preventing infection, and supporting the body system. So, we need supportive care, which is the fluids, electrolytes, and nutrition to manage dehydration and electrolyte imbalances. We have infection prevention, bone marrow transplants, symptomatic treatment, and also potassium iodide. So, si potassium iodide magod is given to block the thyroid's absorption of the radioactive iodine, reducing the risk of thyroid cancer. Okay, now let's talk about the organ-specific effects of acute radiation exposure. So, when we say organ-specific, we have the bone marrow, we have the gastrointestinal tract or the GI tract, the cardiovascular system, central nervous system, the skin, the lungs, and also the reproductive system. So, what are the effects of acute radiation exposure on these organs? Okay, now let's talk about first the bone marrow or sa hematopoietic system. So, ang effect ni radiation exposure, so as little as 1 to 2 gray of the whole body radiation can impair na daw bone marrow function. So, if higher doses are greater than 2 to 6 gray, so it can cause severe na gid nga damage. So, ang damage mechanism niya, radiation kills hematopoietic stem cells, disrupting the production of the white blood cells, the red blood cells, and the platelets. Now, for the gastrointestinal or the GI tract, so can you see GI tract is the lining of the intestines. So, it is very vulnerable to radiation due to the rapid turnover of the epithelial cells which are responsible for the nutrient absorption manggod, and also maintaining the barrier against the pathogen. So, ang effect niya when it is exposed to radiation, so ang GI damage daw occurs at doses above 6 grays with severe effects seen between 6 to 10 nga gray. So, what is the damage mechanism? So, radiation destroys the rapidly dividing cells in the intestinal crypts, leading to a breakdown of the mucosal barrier. So, this will result in epithelial cell death, intestinal wall breakdown, and fluid loss and electrolyte imbalance. So, muna yung mahitabo sa atong GI tract if it is exposed to radiation above 6 gray. And then, for the cardiovascular system, so when we say cardiovascular, it involves the heart and the blood vessels. So, they are generally less sensitive to radiation in the acute phase, but they can be very affected at very high doses. So, particularly in localized exposure. So, for example, during radiation therapy. So, unsa may effect ni radiation sa atong cardiovascular system. So, significant acute effects occur at doses greater than 20 gray daw. So, ang exposed to radiation causes endothelial cell damage and myocardial damage. So, mo na damage nga mahatag ni radiation if you're exposed to doses greater than 20 gray. And then, for the central nervous system, so ang involved sa central nervous system is the brain. So, the brain and the central nervous system and also our nerves. So, the central nervous system and also the brain are relatively resistant to radiation at low to moderate doses, but are severely affected by very high doses, particularly because the neurons are non-dividing cells. So, ang primary concern sa ato ang central nervous system radiation damage will be the blood-brain barrier and the surrounding vasculature. So, ang effect ni radiation exposure, ang damage daw occurs at doses above 10 to 20 gray, and ang iyang damage will be the cerebral edema, vascular damage, and neuronal damage. So, that is for the central nervous system. As for the skin also is affected by high doses of radiation, especially in localized exposures, such as in radiotherapy and also the close-range radiation accidents. So, the damage to the skin cells can manifest as what we call the radiation burns. So, ang effects ni radiation exposure or the skin damage can occur with doses as low as 3 gray, but with more severe effects at higher doses. So, ang iyang damage mechanism will be erythema, desquamation, ulceration, and necrosis. And then, as for the lungs, ang effect sa radiation exposure sa lungs will be inflammation of the lung tissue and fibrosis in the long term, so leading to reduced lung capacity. And then, for the reproductive system, particularly the ovaries and the testes, so they are sensitive actually to radiation as they contain rapidly dividing germ cells. So, ang effect sa radiation exposure, so as low as, mentioned it here, doses as low as 0.1. So, very minimal lang exposure sa radiation can cause temporary sterility, while doses of 2 to 3 gray can cause permanent sterility. So, the damage mechanism, so radiation damages germ cells leading to infertility. O, sa Bisaya pa, mabaog gyud ka. Okay, if you are exposed to very high doses of radiation, makabaog, kibali siya. Okay, now let's talk about the long term. I mean, na-discuss na to ang long-term health effects sa high-dose radiation. Now, how about for the low-dose radiation? Unsa may mga long-term health effects? So, we have here, letter A is the cancer risk. We'll be discussing cancer risk and also the genetic mutations and hereditary effects. Now, again, the cancer types associated with low-dose radiation, we have the leukemia, the thyroid cancer, the breast cancer, lung cancer, skin cancer, and also we have other cancers. So low-dose radiation can also increase the risk of stomach, colon, brain, and also bladder cancers. So those are the cancer types associated with low-dose radiation. Now, how about the genetic mutations and hereditary effects? So, ang potential genetic effects, we have the chromosomal aberrations. So, si radiation can cause rearrangement in chromosomes that may lead to congenital malformations in the offspring and also the increased risk of genetic disorders such as Down syndrome. So, again, Down syndrome is the effect of chromosomal aberrations. So, genetic effect na siya. And then the second one is the increased mutational burden. So the children of parents exposed to radiation may inherit daw an increased burden of DNA mutations, potentially increasing their susceptibility to diseases like cancer. So, ma-inherit nila ang burden of DNA mutations. And then, we also have the long-term non-cancer effects sa low-dose radiation. Kato ganina, long-term cancer effects. Kani siya, long-term non-cancer effects of low-dose radiation. So, in addition to cancer, low-dose radiation exposure has been linked to other long-term health issues including, we have the cardiovascular disease, we have the cataracts, and cognitive and neurological effects. So, those are the non-cancer effects na long-term nga effect when you're exposed to low-dose nga radiation. So, low-dose radiation na gani na. How about kung high-dose radiation na imong exposure? Okay, now let's talk about the radiation-induced diseases. So, let's talk about let's dig deeper into leukemia, thyroid cancer, and also other radiation-induced diseases. Now, let's discuss or let's understand their pathophysiology and also their preventive measures for each of these radiation-induced diseases. Now, let's start with leukemia. So, kanisi leukemia is a type of cancer that affects the blood and also the bone marrow, leading to the overproduction of abnormal white blood cells. So chronic exposure to ionizing radiation is a known risk factor, particularly for AML and CLL. So ang mechanism ni radiation-induced leukemia is the DNA damage, the genomic instability, and the latency period. Now, what are the preventive measures, or how can we prevent, or what are the measures in which we can prevent leukemia? So first one is the occupational safety. So implementing strict regulations and safety protocols in environments where radiation exposure is possible. So it helps reduce the exposure sa radiation. We also have monitoring and also public education. Okay, not all are educated when it comes to unsay buhaton to minimize the exposure to radiation. So those are the preventive measures para maiwasan or ma-minimize ang leukemia, para dili mas ma-minimize nato ang pagkakuha nato sa radiation-induced disease like leukemia. Okay. Now, how about the thyroid cancer? So, what is the pathophysiology of thyroid cancer? So, si thyroid cancer, particularly the papillary and the follicular thyroid carcinoma, has been linked to exposure to radioactive iodine isotopes. So, the thyroid gland manggod, ang atoang thyroid gland is highly sensitive to radiation, especially in children and adolescents. So, ang mechanism of radiation-induced thyroid cancer is we have the cellular uptake of radioactive iodine, we have the DNA damage and mutation, and also the latent period. Now, what are the preventive measures para ma-minimize ang risk of having thyroid cancer? So, we have the screening and surveillance. So, screening of high-risk populations can lead to early detection and treatment. We have the public health guidelines and minimizing medical exposure. So, implementing protocols for the judicious use of diagnostic imaging that involves radioactive materials helps to minimize unnecessary exposure, particularly in children. So, di po maayo nga ang children is always exposed to radioactive materials. Okay. So, we have other radiation-induced diseases. We have the breast cancer, lung cancer, and also skin cancer. So, if you are if there's a chronic exposure, so mas naapoy taas po ang risk na you will get this type of other radiation-induced diseases. Okay. The next topic that we will be discussing is all about the dose-response relationship in radiation exposure. So, let's talk about the concept of the dose-response relationship. We also have the types of the dose-response relationships and the dose ranges and the biological responses. Now, let's discuss first the concept of the dose-response relationship. So, if we will define dose, so dose refers to the amount of radiation energy absorbed per unit mass of tissue, typically measured in grays or millisieverts. And also, we have what we call the cumulative dose. So, it is the total radiation exposure over time which can influence health outcomes. So, kay dose-response relationship man ta, so we will also define response. So, we have what we call the biological response. So, it refers to the effect of radiation on living organisms, including cellular damage, mutations, cancer development, and other health effects. And also, as for the health outcomes, so the observable effects on health, including acute effects, for example, radiation sickness, and also long-term consequences like cancer. Okay, so we have three types of dose-response relationship. The The first one, we have the linear non-threshold model. We have the threshold model and the Hormesis model. Now, si linear non-threshold model or si LNT, so this model posits that any amount of ionizing radiation can increase cancer risk. So, there is no safe threshold on this one. So, ang application ani commonly used in radiation protection standards, especially for low doses of radiation, such as those encountered in occupational or in environmental settings. So, as for the implication, so even low levels of radiation exposure are considered harmful, of course, emphasizing the importance of minimizing exposure. So that is the first dose-response relationship, or the what we call the linear non-threshold model, or LNT. Now, as for the second one, which is the threshold model, so this suggests that there is a certain threshold dose below which no significant biological response occurs. So only above this threshold does the risk of harmful effects increase. Now, for the application of the threshold model, so some studies indicate that certain acute effects, for example, skin burns, may only occur above specific dose levels. And as for the implication, so in cases of high dose exposure, establishing a threshold may be useful for understanding the immediate biological responses. And then we have the third type, which is the Hormesis model. So, kanisi Hormesis model proposes that low doses of radiation might have a beneficial effect. So, potentially stimulating repair mechanisms and also enhancing the immune response, thus reducing the cancer risk. So, for the application on this model, so kani siya nga model remains controversial and is not widely accepted in the context of radiation protection. So, this kani siya nga model suggests that not all radiation exposure is detrimental, but further research is needed. Now, let's talk about the dose ranges and its biological responses. So, katong kaganina na-discuss nato ang mga dose ranges and its effect on the body systems. Kani siya, ang biological response na pud nato niya ang ato ang tanawon on the different ranges of the dose. Okay, so for the low doses or less than 100 millisieverts, ang biological response niya, the body may experience slight cellular damage which can often be repaired by natural mechanisms. And then, for the health outcomes, increased cancer risk is generally assumed, but the evidence is more uncertain compared to the high doses. So, long-term monitoring of population exposed to low doses, such as the survivors of Hiroshima and Nagasaki, has shown a modest increase in cancer incidence. Okay, now for the moderate doses, which is from 100 millisieverts to 500 millisieverts, higher rates of DNA damage and potential for mutation, and also the body's ability to repair damage may be overwhelmed. So, mo na biological response if you're exposed to moderate doses. And as for the health outcomes, increased likelihood of cancer, particularly for radiosensitive tissues like thyroid and breast. So, acute effects may include mild radiation sickness if the exposure is concentrated over a short period. And if you are exposed to high doses or greater than 500 millisieverts, ang biological response niya will be significant cellular and tissue damage, overwhelming of repair mechanisms. Possible acute effects, including radiation sickness, cellular necrosis, and even death. And as for the health outcomes, there is a substantial increase in cancer risk with the potential for immediate health effects such as the ARS or ARS, acute radiation syndrome, and also we have the long-term effects. So high cancer incidence, particularly in the hematopoietic system, which is our bone marrow, and solid tumors. Okay, so muna yung mahitabo. Those are the biological responses depending on the ranges of the dose. So low dose, baka ang imong exposure, moderate, and high doses. So it has different biological response when it comes to the different dose ranges. Okay, now let's try to apply risk assessment models. So unsa may mga risk assessment models to evaluate and quantify the risk associated with radiation exposure. Okay, so the first one is we have the hazard identification. So under sa hazard identification is we need to identify the types of radiation, kung alpha, baka, beta, gamma, x-rays, etc. And also ang sources of this radiation. So medical procedures baka sa occupational exposure, or even sa nuclear accidents, etc. So the second one is the biological effects. So let's understand the biological effects of radiation, including the DNA damage, the cell death, and potential carcinogenesis. So that is the first process. The second one is the dose response assessment. So under the dose response assessment is we have the dose metrics. So we will define i-define nato ang dose metrics. So pila ang absorbed dose in grays, equivalent dose in sieverts, and then we have the linear no threshold model or LNT. So it is a commonly used model that assumes any amount of radiation exposure carries some risk of cancer with no safe threshold. And then also, the third one is epidemiological data. So we will utilize data from studies of populations exposed to radiation to establish this dose-response relationship. And then the third process is the exposure assessment. So, sa characterization of exposure, so i-assess nato ang scenario, exposure scenario, including the duration, the intensity, and also the type of exposure. And then, as for the measurement techniques, so we will use dosimetry and radiation detection methods to quantify exposure levels in affected populations. Now, the fourth one is the risk characterization. So, under the risk characterization, we have the population attributable risk. So we estimate the proportion of cancer cases in a population attributable to radiation exposure. And then as for the risk estimation, so we will apply risk coefficients derived from the epidemiological studies to the estimated dose to quantify individual and also population risk. And then as for the fifth one, we have uncertainty and variability analysis. So, we have the sources of uncertainty and sensitivity analysis. So, the sources of uncertainty, we will identify the uncertainties in the dose-response relationship, the exposure estimates, and the biological responses. And as for the sensitivity analysis, so we will conduct sensitivity analysis to understand how changes in these assumptions affect the risk estimates. And then the sixth one is the communication of risk. So we have the public health implications. And the seventh is the regulatory framework. So we have guidelines and standards. So incorporate findings into regulatory frameworks. So for example, recommendations by organizations like sa International Commission on Radiological Protection para ma-establish nato ang safety limits and protection measures. So, combining the radiation biology principles with epidemiological data, it provides a comprehensive framework for assessing risk associated with radiation exposure. So, if there is a continuous monitoring, research, and adjustments to models based on the new findings are essential for the effective risk management. Okay, now how about the implementation of protective measures para ma-minimize ang biological effects sa radiation? So, we have here effective shielding. We have safety protocols, personal protective equipment or PPE. So, muna yung mga strategies. We have training and education. It's very important. We have environmental controls. Okay, dili man nato makontrol si radiation or dili man nato makita si radiation kung unsa na nga dose ang na-expose ta. So, might as well have this environmental controls. Pwede man nato makontrol si ventilation systems and also the waste management. So, safe handling of the waste, the storage, and disposal of radioactive waste. And then the sixth one is the regulatory compliance. So, you must adhere to the standards nga gina-provide or gina-set sa mga agencies. So, for example, sa US, we have the International Atomic Energy Agency and also the US Environmental Protection Agency para ma-ensure ang mga safe practices. Okay. And then, we also have the regulatory guidelines and safety standards for radiation exposure. So, here are the 6 guidelines, regulatory guidelines, and safety standards. So, the first one is identify the relevant regulatory bodies. So, dapat kabaluta sa mga regulatory bodies, or we must familiarize ourselves with the guidelines from the organizations. Let's say, for example, from the World Health Organization, sa kung unsay regulatory body sa imong country. And then number 2, we have review key regulations and standards. We have number 3 is the implementing guidelines. We have training and education. We have regular audits and reviews, and also documentation and reporting. So, by applying these regulatory guidelines and safety standards, so the organizations can create a robust framework for radiation protection. So, if there is a continuous education, atay monitoring and improvement sa atong safety practices, then it will help to ensure compliance and protect the health and safety of not only the workers but on the public. Okay, so I think that's it for our discussion for today, and I hope you've learned so much, and we'll see you again on our next discussion. Thank you very much for listening.